Hello and welcome to another episode of the Oxford MAT Livestream. My name's James and I'm joined again by Flora.
Hi.
And also by all of you in live chat underneath there. The chat is over at slido.com/matslive, or you can follow the link in the YouTube description, or if you're on the Mat Live homepage, there's a link to the chat over there if you want to join in. Hi to Neil and Will and Jenny and George, other people who are in chat as well are joining now. People are joining anonymously as well. You can join anonymously if you want to. That's allowed. We're going to start with some maths like we always do. I've been thinking about the difference of two squares. Difference of two squares is one of my favourite things. Let's see if I can spell difference. That's the hard bit, really. Difference of two squares looks like this. A squared take away b squared. Hi Tommy, hi Ali. And this factorises really nicely. I'd like to talk about this factorisation in a couple of different ways, just quickly. So you've probably seen before that this factorises like this. A plus b. Okay, which you can think of as just being, a true fact, that if you multiply out first, inside, outside, last, then you get the right terms, the middle things cancel out. First, inside, outside, last being file, my way of remembering how to get all of the brackets. But you could also think of this in terms of the solutions to this equation. I think I've lost Flora. Yep, I've lost Flora. Oh no. I've got Flora back again. Hi Flora. You're muted again, Flora.
Hi, sorry about that. It's my internet. It's bad.
So, I suppose we could be thinking about the factorisation of a squared minus b squared. You could also think about it as the solutions to a squared minus b squared equals 0. You can think about when that's true. We've got techniques for solving equations like this. This rearranges to a squared equals b squared, from where I would say either a equals b or a equals minus b. There's like a plus minus sign in there from doing the square root. And those are precisely what I get for these two brackets. So there's a term here, this bracket is 0 when this is true, and there's a term over here, a equals minus b, which is true when this bracket is 0. So we could think about those brackets as being what are the solutions to these equations for a in terms of b, which you also know. I suppose I'm telling you again that if two brackets multiply to 0, then one of them 0 or the other one's 0. We got more like that today on the Polynomials live stream. Right, okay. Brilliant stuff. Hi everyone, I hope you're doing all right. Someone with the username Grant Sanderson has turned up, which will be very exciting for everyone in chat.
Everyone's quite excited that Grant's back.
Brilliant. Almost certainly not Grant Sanderson, but never mind. We always start with a poll when I remember. Today's poll is, how do you feel about polynomials? Flora, I'm going to very rudely replace your face with the...
It's fine, don't worry.
If I can work out how to do that. No, not that. This one. Oh, okay, right, so people are voting on how they feel about polynomials. It's currently going really well, between 4 stars and 5 stars. 5 stars being...
great.
Yeah, I know. 5 stars love polynomials. 4 stars is winning slightly. 1, 2 and 3 stars. Oh, no one really. Oh, a couple of people. I think there's one person in each of those categories, 1, 2 and 3 stars. I'm always watching out for people who pick 1 star or 2 stars or something like that. But this is much more unanimous. I can't remember what the average score was last week. But this week it's at 4.3 at the moment, which is pretty good. People feeling pretty happy about factorising polynomials. While people are voting, let's have a quick look at the MAT syllabus. The mathematics submissions test has something to say about what people should know about polynomials by the time they sit the maths in November of year 13 or equivalent. It just says the quadratic formula, completing the square, discriminants, factorisation, and the factor theorem. Brilliant! Look at that! Look at that distribution as well. It's like not quite what's that curve called? It's not quite a Poisson sort of curve. It's just 4 and 5 stars, averaging out about 4.4 stars. Amazing stuff. Thank you. Let's see what people are saying in chat. Somebody wanted a 6 out of 5 option. Amazing stuff. And somebody's done the Polynomials pun in chat. Is that on screen? Has that made it on? Good job, Mol. Polynomials. Right, okay. Molly name. There's a pun in there based on Molly's name. I haven't quite pulled off. Right. Okay. Good. Flora's back. There's some revision content on the sheet. Is Flora back? Oh, I might have lost Flora again. I'm gonna switch like this again while I try and connect to Flora again. There's some revision on the sheet about what the discriminant is, about what the factor theorem is. It tells you that if a polynomial is 0, then x minus a is a factor. If you're interested in that. I've tried to put in my happy and sad fact about quadratics. Hi, Anthony. And then on the sheet, which is available on the MAT Live page, there's also some warm-up questions, and we're going to talk about some of them. Taylor Swift in chat says, do we need to know the trapezium rule? Which is a good question. Trapezium rule is not anymore. Trapezium rule used to be on the MAT syllabus, no longer on the MAT syllabus, so you don't need to know what the trapezium rule is. We've actually covered now the entire MAT syllabus has now been contained in the first 8 episodes of this MAT Livestream, finishing with this one. We've gone backwards through the MAT syllabus, but that's it. That's now all of the maths on the MAT syllabus. Right, cool. I'm going to hand over to Flora, who's back again.
Yes, I'm back again.
Hello. Guess who's back? Back again. Flora's back. Tell a friend. Okay. People want to do warm-up questions, and then if we've got time, we'll do some MAT questions as well afterwards. But yeah, I'm going to hand over to Flora, and I'll hang out in chat a bit for some of these warm-up ones.
So here I am, and here are some warm-up questions. I'm going to start with this first one that I've circled. For which values of k does x squared minus x plus k equals 0 have exactly 2 solutions? So if you've read the revision material, then you will remember that with every quadratic we have this thing called a discriminant, and that tells you how many real solutions the quadratic has. If the discriminant is greater than 0, there's 2, and so on. So here the discriminant is always b squared minus 4ac if the quadratic is ax squared plus bx plus c equal to 0. So here you can identify that b is minus 1, c is k, and a is 1. So the discriminant is minus 1 squared, which is 1, minus 4 times 1 times k, which is 4k. So if we want this to have exactly 2 solutions, then we want 1 minus 4k to be greater than 0. A cheeky bit of rearrangement gives that we want 4k to be less than 1, k less than a quarter. Someone shout me if I mess up the algebra. So that is basically the answer for that one, and it says exactly 2 solutions. It doesn't say kind of up to 2 or whatever, so we want less than a quarter. So then moving on to the next one, you may be thinking, okay, that looks very similar to the one before, and you're like, well, yeah, it is very...
Oh no, we lost Flora mid-sentence. No. It is similar to the one before. Flora's going to say that these quadratics, this next one, which is not quite a quadratic, is similar to the other one. Oh no. It's the internet. Flora's changed to a different internet connection by moving into Oxford. Somebody in the meantime has asked when's the deadline to register and sign up for the MAT, which is the 15th of October, which is also the UCAS deadline for applying. They also want to know when they pay for the MAT, and it feels like a good point to say that Oxford doesn't charge people to take the MAT, but your test centre might charge you admin for sort of invigilation or something like that. Okay, and I'm now approving puns in chat. Why not less than or equal to? Well, if it's equal, we get 1 repeated solution, which is not quite what we want. Okay.
Hi, real sorry about that.
It's alright, I answered a question from chat. I think you're about to say that this second one you've circled,
yes,
starting x to the 4, looks a bit like the previous one.
Yes, so I was going to say we can substitute. I'm going to say let y equal x squared. So then what we will have is y squared minus y plus k equals 0, which is the previous one. So we know that, looking at the discriminant, this quadratic, in terms of y, has 2 solutions when... Sorry, that's a bit messy. 2 solutions when k is less than a quarter. And then if we had said we wanted like exactly one solution, then we would have kind of go back up here and think, okay, you would have 1 minus 4k equal to 0. So then you would have 4k equals 1 and k equals a quarter. So for one solution, you'd have k equals a quarter. And then funnily enough, for no real solutions, you would have k greater than a quarter, because we would simply kind of swap the order of these, like that. So k would be greater than a quarter. Except here, we're not just thinking about y, we're thinking about x. So in terms of y, we'd have two solutions for y if k is less than a quarter. But if we have two solutions for y, and then y equals x squared, we might have more than two solutions for x. And that depends on, well, basically whether y is positive or not. Because if you think about it, you can only have real solutions to y equals x squared if y is...
Yeah, y is positive, yeah.
Y is positive
or
number.
0, I guess, yeah.
Yeah, or 0, obviously. So here we have to think if we have, but then we would have more. But then if y was less than 0, then it wouldn't have any square roots. Not real ones, anyway.
Yeah. I guess your table on the right here, where you've written two solutions, you're talking about two solutions for y, and I think there's actually quite a lot of possibilities. There's actually quite a lot of possibilities. I think I'm talking to Flora without internet, but I'm also talking to you at home. If there's two solutions for y, there's actually quite a few possibilities about what could be going on for x. Because if those two numbers for y are both positive, then I'll get 4 solutions for x. If one of the y solutions is positive and one of them is negative, then my x solutions, I'll get two solutions for x from the positive y number, but I won't get any real x solutions from that negative value of y. So I've got to be really careful. It could also be complicated if one of them is 0, because if one of those two solutions is 0, then, oh dear, I'm taking plus or minus square root of 0. So within this two solutions bit, there's actually a fair number of possibilities. Hi again, Flora.
Hi.
How's it going? The internet was much better during our warm-up, right?
Yeah.
I was just saying that in the two solutions case, there's actually lots of possibilities depending on whether those solutions are both positive, both negative, one of them's positive, one of them's negative. It really matters. But I suppose actually, in this case, where there's two solutions because k is negative, I think it's, for this particular one, I think it's actually the case that one of them is positive and one of them is negative. One of the y solutions is positive and one of them is negative.
Yeah. And if one is positive and one's negative, then that means you will have two solutions for x.
Right, yeah, okay, which is really good. The reason I know one of them's positive and one of them's negative is this constant term in the polynomial, this bit here, this is what I would get if I multiplied the roots together, because I know if this factorises as something like y minus roots, y minus the other roots, that constant term would be the product of the roots. And here the constant term is positive, so I know that I've got one positive solution for y and one negative solution for y. So this is actually really good. It means that in this case, I've got one positive and one negative. The reason that's really good is that the positive solution will give me exactly two solutions for x, and the negative one won't give me any solutions for x. I should probably have put the word real on this sheet quite a lot more.
Yeah, we were kind of assuming that it's real solutions.
Yeah. Where shall I write the word real? I might write real. I'm going to write real up here.
Just keep it real.
Keep it real. When I wrote the worksheets, I hadn't realised that chat was going to be so obsessed with complex numbers and writing down complex roots of things.
Yeah, exactly.
So I might put in here exactly 2. In here I want real solutions. And in here I want real solutions. And now it makes the question much harder as well. Okay.
Yeah.
Brilliant. Okay. This one where there's one solution and k equals a quarter, this case is quite interesting. I think I know what the roots are. I think they're both 1/2. What do you think, Flora?
I think that's...
Right, we might change the text style up very slightly in a moment because we're dropping Flora quite a bit. I think this is true. That in this case, y is 1/2, so my solutions for x are plus and minus 1/2, root 1/2, which is good because there's 2 of them. So I just get 2 solutions in that case. Do I get any more solutions? I'm not sure I do. Okay. Okay, brilliant. So different cases, different things. I think in this case, if there's no real solutions for y, then there can't be any real solutions for x. Because if x is a real number, then y equals x squared, y is going to be a real number as well. Okay. Hi again, Flora. Should we try without... I'm going to turn off your video and see if that makes
I was going to say that
better.
might be a better idea.
Yeah. Okay, Flora's going to become a sort of disembodied voice.
Yeah, I was just saying how, yeah, I agree, it is 1/2 the solution, but then it cut out.
Okay, I've gone through the other cases as well, I guess. Oh, no, you've connected and your text has appeared. Oh, syncing. Right, okay.
Oh, it's okay.
I was going to mention a different approach to these ones as well.
Yeah.
Where's one of the solutions negative for k less than a quarter? Oh, yeah, that's a good point.
I was going to say, you were talking about k being less than 0. I think we need to separately consider the case between 0 and a quarter, but my video and audio cut out so many times I hadn't got around to mentioning.
No, I don't think enough people called me out. Wait, so someone with the username LMAO has told me that I confidently asserted a while ago that if k is less than a quarter, then it's negative, which is not true.
Indeed.
So
I think you were thinking it was minus a quarter. Quite
possibly. Okay. All the stuff I said before about having the product of the roots being negative, that's true if k is negative, for which I need k to be actually less than 0. Okay,
Indeed.
Good stuff. And Aris, aka Ross, has got the combined final answer, which is correct, that I want either... There are 2 possibilities here, really. Either k less than 0, or... k equals 1/4.
Exactly.
Brilliant.
Got there in the end.
We got there in the end, between all of us. Thank you, chat. People have got to point out, I'm going to quickly check, did anyone point that out when I did it? People have got to point out stuff as well. Oh, someone's asked if I know Lizzie Fry. I know the name. I've worked with Lizzie on... Oh, what did I work with Lizzie on? Can't remember. Okay. There's a picture you can draw for these questions as well. For these ones with a different parameter in, different values of k, I sometimes like to think about drawing the picture with different values of k, or moving k over to the other side and thinking about intersections. Do you know what I mean?
Ooh, yeah, I do. That's a good idea, actually.
Do you want to draw the picture? Or should I draw the picture? I feel like I'm muscling in on your warm-up.
No, you can draw the picture. I trust your graph sketching more than mine.
Okay. Right. People at home, I'd like you to try and sketch... the curve x to the 4 minus x squared. Because I'm thinking of this equation as being x to the 4 minus x squared equals negative k. I'd like to try and explore this one and work out where those 2 different cases come from. Okay, so at home, grab a bit of paper and sketch for me this left-hand side function, x to the 4 minus x squared. And someone in chat immediately says, it's Desmos time. A polynomial with 2 terms? We're going to need a computer to help out. Good stuff. I guess you can just about... Some people have got these kind of clever emoji keyboards where they can type things. And I think you can almost draw a picture of this probably in ASCII art. I'm not quite sure how I would. Yeah, I think I can imagine drawing a picture of that with ASCII art for chat. Okay. Somebody said that makes so much sense now, and I haven't got to the bit where it makes sense. So maybe they're ahead of me. Okay. Can somebody describe to me what does their picture look like for x to the 4 minus x squared?
It's always fun when people try and describe graphs with words.
Yeah. Are you playing along at home? I should do that thing like CBeebies, where I leave a pause for you to talk back to the TV.
Yeah.
People are telling me about where the roots are. Thank you, George. George has factorised it. And people are here telling me about people are using ASCII art to try and draw me a picture of what this looks like. We've got the word wobbly. We've got roots. People have gone for the ASCII capital W. Emily says big W. Lovely stuff. Molly's got that keyboard. Adding K. Molly makes a good point. Adding K to this equation is a bit like translating it upwards. So you can think about taking this graph, which everyone's told me looks like a W, and you can think about translating it up and down if you like. I like to think about that as in terms of intersecting this curve with the line y equals minus k. But you could think of this as a translation up and down if you wanted to. A translation or a W. Grant with the wisdom again. Right, okay. Y equals minus k. Okay, so the question asks, when do you get exactly two real solutions? And there are two possibilities. Firstly, if your line is really high up, then you'll only get 2 points of intersection with the W shape. You'll be up the top of the W. That happens if negative k is positive. So that happens if k is negative. Or there's this other really special case where you're exactly here, touching the bottom of the W, which corresponds to some particular value of k down here. If your value of k is just right, then you get two real solutions because you hit both minima of the W. So a math question could ask you to sketch that, work out where the minima are, and then talk about value of k, and then maybe do the long way round to get there. Okay, right.
Cool.
Has anybody checked Ali's binary? You were moderating chat. Is that a binary for W, or is that a binary for something obscene?
I don't know binary for W. I'm sorry, everyone.
We're assuming that's the binary for W and not for something obscene, right?
Yeah, I mean, I read it, but I didn't, you know.
What's the binary for... Can you put YouTube URLs into... Can you rickroll someone in binary? No, maybe not. Right, cool. Okay. Chat was getting... I think for the maths club, chat was getting more and more inventive about trying to get me to play Rick Astley during live streams.
Oh, anyway, absolutely. Yeah. Multiple Rick rolls occurred. Definitely, because everyone's always trying to like, oh, here's a really interesting resource that I want to share with you, and then, oh no, another Rick roll.
Someone wants the how's your day going poll, which I will turn on.
Nice. Cool.
Yeah, why is it positive a quarter is a good question. I'm still reading out chat behind the poll. It's positive quarter because this is the line y equals minus k. So down here is a line y equals, this is the line y equals minus 1/4 to hit both minima, but it's the line y equals minus k because I moved this k onto the other side. I suppose that doesn't mean anything deep about mathematics. It's just which side of the equation the k's on. Here it's on the left, but possibly if it was on the right, then you can think about that being positive k instead. It is confusing. It's an extra minus sign. Thinking about mixing around. Brilliant, cool. Now people are taking me up on the invitation and trying to rickroll me with binary, which brilliant. How's your day going, everyone?
People are inventive.
People's day is going roughly 3.6, which is not as good as
bad.
It's been before.
Could be worse.
Could be better. Could be worse. It's good. 4% on 1 star, and people prefer polynomials to how their day is currently going. So if we fill the rest of the day up with polynomials, then
then it'll be better.
Bring the average up, right?
Yeah. Oh, someone's asked us how our day's going, which is quite nice.
Ah, lovely, thanks.
My day's good. I've not done much.
Went to a nice coffee shop that's nearby.
Nice.
Working from home, lovely. Right, cool.
I was going to say, shall I press on and try another polynomial?
Oh yeah, let's do another polynomial warm up.
Okay, so check that p of 17 equals 0. So I want to check that for me, that I can press on and factorise p of x.
I remember writing this one. So check that p of 17 is 0 means plugging in 17, right?
It just means that we're going to do 17 cubed minus 13 times 17 squared minus 65 times 17 minus 51. But I'm sure my time is better spent showing you a nice way to factorise a cubic. So.
Okay.
That
does work out to be 0, I think, if you plug in 17.
Wonderful. There's a nice way of doing it with a grid. Some people may have done it with a grid, some people may have done it without a grid. Doesn't matter. So basically, we know from the factor theorem that if p of 17 equals 0, then we know that x minus 17 is a factor of p of x. So we know that we can write p of x as x minus 17 times some quadratic. And you know it's going to be a quadratic because we have to have a cubic. We have to have x cubed. So I'm going to just write in x and minus 17.
Ooh.
So, you okay?
Yeah. No, this is great. I've never seen this box thing before.
Oh, okay, cool. I thought you were saying I'd done something wrong, but that wasn't it.
That's a minus 17.
Yeah, I know. I just wrote it badly. Okay, so the point of the grid is on the outside of the grid go the factors. So obviously x minus 17 is one of the factors. The other factor is going to be x squared plus something. And inside the grid needs to add up to p of x. So we're off to a good start. We've got x cubed in the first box, and we kind of work down and then diagonally. You'll see what I mean because I'll go through it. So x cubed is x times x squared, so we have to have like x squared on the top to make an x cubed. And then what we kind of automatically get in this bottom box is minus 17x squared. But if you refer back to our polynomial, what we want is minus 13x squared. So how do you get from minus 17 to minus 13? Well, you need to add 4x squared. So I'm going to put 4x squared in this box. So then, what do you need to multiply x by to get 4x squared? Well, that would be 4x. And then, I believe 4 times 17 is 68.
Yep.
So we get minus 68x in that box. Except we don't want minus 68x, we want minus 65x. So we have to add 3x. So 3x goes in this box. So obviously we need to multiply by 3. So 3 times x is 3x. And then 3 times minus 17 is minus 51. And if you get the right constant in the bottom right box, that's like a little check that lets you know that you've done it right. Because obviously you should have minus 51 at the end. There's nowhere else to go. So then we have factorised it into x minus 17, x squared plus 4x plus 3. Happy days.
Yeah, I love the box method. I've never seen this before, and
Yeah,
skimming through chat, people are divided between either people who love doing it like this is how they do polynomial division and indeed normal division, or people who learn how to do sort of synthetic division or just trying to just write this line down, I suppose.
Yeah.
Going one term at a time, which is how I learned to do it and how I sort of struggle along doing things.
Yeah,
I might start doing some boxes. I quite like the look.
One of my teachers taught me the box method when I was like 16, and then when I was kind of in year 13, a different teacher was like, come on, you should be able to do it by inspection now. So I started trying to do it by inspection. But I think the box method is like a kind of stepping stone towards being able to do it by inspection, because when you are doing it by inspection, you're basically doing this kind of thing but in your head. And if the numbers are big and you want to write it out, like, it only takes a couple of minutes. So
yeah, people are talking about the quote long method as well, which I suppose would be the one where you write out the polynomial. Ooh, in pink. Let's have colour people.
Oh, the long division thing.
Yeah, people. I think
I
people
never really got into that. No one ever really taught me long division with polynomials, and it seemed complicated, so I shied away from it and did boxes instead.
Yeah. Okay. Like, does it work like this? And then you do a lot of subtraction, right?
Yeah,
I'm sort of
something like
remembering how
that.
to do this.
Yeah, something like that.
And then you do some subtraction.
Oh, someone's saying, like, how on earth do you do it by inspection? And believe you me, when I was younger...
No. When I was younger, doing it by inspection seemed like witchcraft. Okay, and then some more long division in here. So people are trying to decide how they might try and do this. There's some voting going on in chat as well, in the way of people voting on chat. Oh, George has got another method, which I like as well, which is to write x minus 17 times ax squared plus bx plus c, and then try and solve for a, b, and c. Maybe multiply out and solve by a, b, and c. I think there was a method where you write this 51. Maybe you can start from this end and say 51 is 17 times 3 or something, to factorise that as well. Emily would like a poll. I'm going to do a poll. Yeah, we should maybe explain what inspection is. I think inspection... What do people mean by inspection when they do this by inspection? Possibly just quickly writing down these terms by doing all of this maths in your head really quickly.
Yeah.
I think. Emily would like.
I was just trying to talk about inspection and my kind of internet dipped again. I don't know how much you heard, but I think someone asked if we could demonstrate how you do this by inspection.
Oh yeah, do you want to do that? Maybe.
Yeah, I can do that.
I'm going to scroll down.
Yeah.
There's some space over here.
Yeah, down there is good.
I'm doing a poll as well.
Okay, so this is how I would do it by inspection. X squared minus 65x minus 51 equals. And I mean, this would be hard to do by inspection in my head. I'm going to be writing out little calculations next to it because I wouldn't be able to kind of multiply the numbers in my head. But anyway, here goes. So presuming that I already know you've got x minus 17, because we put in a number and we're equal to 0. Okay, so you've got to think. The first term is x cubed. So to get x cubed, I'm going to multiply x by something. And so we're going to have an x squared somewhere. So start by doing x squared. And then you've got to think, okay, I'm going to have x cubed. And then if you think about the way you expand brackets, the x squared will get multiplied by each of the terms in the other bracket. So you're going to have minus 17x squared. And if you have minus 17x squared, you're going to somehow have to have plus 4x squared so that you end up with minus 13x squared. So how are you going to have plus 4x squared? Well, you're going to have plus 4x, because then plus 4x has to multiply by x, and then you get plus 4x squared. And so then you've got to think, okay, now the 4x will get multiplied by everything. So what do you get when 4x is multiplied by minus 17? Well, you get minus 68x, but we want minus 65x, so you need to add on 3x. But the term that we're going to be writing down next is going to be a constant term, so you're adding on 3, because then 3 times the x that we have over here is going to be 3x. And then, again, similarly to the box method, at the end you can say, okay, well, what's the 3 gets multiplied by the x, and then all the x's are sorted out. But then, what's 3 times minus 17? Well, that is 51. So you know you can kind of draw the bracket, end it, and then you know that you've written it out correctly. So that's inspection, and it's basically a very similar method to the box method, where I just do more stuff.
Yeah, it's similar to the box method, but instead of drawing the boxes, you work it through in your head. People have also got... I'm running a poll at the moment. Let's talk about the poll. People are suggesting other joke answers. I put some joke answers in. I'm not sure if they're all showing up on the live feed. At the moment, long division is winning. I suppose that's this calculation up here. Oh, hello. Oh, that's turned off a poll. There we go. Oh, spacebar turns on and off polls. That's good to know. That explains a lot. Anyway, long division's winning at the moment with 37%, good number, of the vote over here for doing the division like this. Some people like just writing it out. Just work out the numbers in my head, off we go. And I'm interested to see that the box method is doing quite well solving for the coefficients is in there, and then my kind of joke answers are in at the bottom, which is right. People are suggesting more joke answers, like just put it into Wolfram Alpha, or
we do love Wolfram Alpha.
Oh yeah, hi again. Yeah, sorry.
Hi again. I'm back. I don't know if I dipped out mid-sentence.
A little bit.
Sorry.
I think I guessed the rest of your sentence. When you were younger, something about polynomial division. When you were younger, it was what people did or something.
Oh, well, yeah. I was saying about how I don't know.
Yeah,
I was saying
mind.
that a while ago. It doesn't matter. When I was younger, I had to use a grid because I felt like I couldn't do inspection, and I realised that I could.
Cool. And because somebody asked earlier, it doesn't matter which one of these methods you use in a test like the math submissions test. Oxford doesn't mind how you factorise polynomials.
No.
Being able to get the right answer is important, and I guess being able to do it accurately and fluently and without it being too annoying for you. Right, cool. Forcing your older sibling to do it for you. Right, there we go. Needs some precedent, doesn't it? Still focused on that. No, just managed to. I've learned that spacebar is the shortcut for turning on and off polls, which is quite exciting.
That's helpful.
It explains how the other day I turned that poll on without meaning to.
Right. Of course, yeah.
Spacebar. Okay. The warm-up questions then go on to some material about factorising things and talking about the degrees of polynomials.
Yeah.
Do you want to discuss the degree questions?
Yeah, I think I'll discuss the degree one, and then maybe you want to do some math questions.
Oh yeah, I think so.
Yeah. So let's talk about degrees. So what's the degree of the polynomial brackets x squared plus 1 to the power of 10? So you may be thinking, surely they don't expect me to expand that bracket, and if so, you'd be right. We do not expect you to expand that bracket. Here, you're going to think, well, if I multiplied, for example, x squared plus 1 times x squared plus 1, you know that the first term, and when I say the first term, I mean the term with the highest power, is going to be x to the 4. And then you're going to have some other terms like that, but they are all going to be like x cubed, x squared. Well, they're not going to be x cubed in this case. They're all going to be x squared, or they're going to be constant terms. But then there's not going to be another one that's that high. So similarly, when all these brackets get multiplied together, the highest power that you're going to get is x squared to the power of 10
The suspense is killing me. Oh, Flora, internet. Okay, right. X squared to the power of 10 is x to the 20. I'm pretty sure Flora was about to say. That's the biggest power. I really like this. Is it just 2 to the 10, says someone in chat? And I think it's not. I think it's 2 times 10, because of this is like some powers ruled stuff, like indices, right? X squared to the power of 10 means x squared times 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 x squared, which, if you're following along, is x to the power of 20. It's 10 copies of x squared, all multiplied together. Yeah. X
Hi,
to the 20.
again, I don't know how much you heard.
We got to x to the 20. We're at x to the 20, highest power of x.
Yeah, I was just saying how I visualise all the x squareds getting multiplied together. Because obviously when you have something like this, you look at the highest power in each bracket, and then you multiply them together to get the highest power overall.
Nice. So that gives you the degree of the polynomial, the highest power that there is in that polynomial, which is pretty good. We just have to work out all of the other terms. We know how to with the binomial, but we didn't have to do it.
Yes.
Next question. What's the
degree of that one? Well, you know that basically you've got okay, they're just the odd numbers, so it's like half of 2021, except plus 1.
Yeah. it's like half of them, isn't it? But with an extra.
Yeah, it's half of 2022, so you'll have 1,000 and
1011. Yep, there we go. I really like the way you think about that, by the way. I
Yeah.
think lots of people might try to write down an arithmetic sequence or something, but when you've seen a lot of these, like how many odd numbers are there, you develop these kind of rules for yourself, like a little mnemonic, or it's half of them, but I'm not going to get caught out. I'm going to add one because I've got the first and the last one in there.
Yeah, exactly. I mean, when you think about it, you've only got x's, you've not got any fractional powers. So it's a bit of a sanity check. If you thought, what's the degree of the polynomial? Oh, well, if I multiply all these together, it's going to be half of 2021. And then you're like, oh, that's not a whole number. You know that's not going to be the right answer.
Right. Yeah, it's whether you round it up or down.
Yeah, exactly. And then think about differentiating each of these polynomials, but don't actually do it. What would be the degree of the resulting polynomial? So this is basically just, do you remember what differentiation does to the degree of a polynomial? If you think about differentiating it once it's fully expanded, the power of each term will go down by 1. And if the power of every single term goes down by 1, then the power of the highest term goes down by 1. So what you will have is x to the 19 and x to the 1010.
Yeah, nice. Okay, I really like that we get that information without actually doing like the differentiation.
Oh, absolutely. Who wants to differentiate that? Not me.
Yeah, exactly. Oh. No, I actually really don't want to differentiate it.
Indeed.
Okay, cool.
Great.
Should we do some math questions? Or...
Yeah, of course.
Yeah, let's do some math questions. One of the math questions looks a bit like that. It's all about differentiating polynomials. That's the thing about the warm-up questions. Sometimes they're very particularly warm-up for particular math things. So I'm going to translate sideways and look at a math question. If you're following along at home, this is the next page of the worksheet. Or if you're on the website, it's further down on the website. I think I want to talk about this question. It's a bit ugly, isn't it? Look at all this question. So here's the math question. It's 2013 question 1E. It says the horrible expression involving some second derivatives, and a first derivative and some polynomials with brackets multiplied together, just like Flora had now. Is a polynomial of degree, and then we're supposed to complete the sentence by choosing, is it a polynomial of degree 9, 8, 7, or less than 7? And the hint that I've added for the worksheet, hint's not part of the math question, wasn't on the sheet. The hint is that you don't actually need to differentiate the entire thing inside the brackets. Okay, and some people have been rushing ahead. Maybe they looked at the question sheet already and would like a poll. So I'm going to turn on a poll, which sort of replaces chat. And also I'm hiding the results, so there's not much in the chat box at the moment. But people are also talking in chat to say, what are we going to do?
Someone's asked if you can put hints in the actual mat.
We do sometimes put hints in the mat. There are sometimes in square brackets, hint, : consider something, or do
Yeah,
this bit
sometimes.
First.
Yeah, but I think they might not be as helpful as your hints.
The hints. When we put a hint in, it's supposed to be helpful.
Yeah, I know.
Yeah, sometimes that's the simplest way to ask the question. To get the question. Okay. While people are voting and thinking about this question that's on the screen, Matt question writing chat. Sometimes that's the most easy to understand order, to have the question first, so that you get the idea of what we want people to do, question mark, and then explain how you might do that, so that you see what we're trying to do, what we're trying to get you to do, and then see the hint, rather than having to read through in sequence, read through what you're kind of doing, and then a hint about a step along the way, big comma, and then also now the main chunk. It looks very intimidating because it's lots of stuff. But if you sort of say, here's where we're going, please do this first bit first, in the hint, I don't know. It's a slightly different structure that we've tried out. People in chat are trying to bribe me, which is not working very well. Okay.
Yeah.
And they've also asked if we've checked it for mistakes. We have checked it for mistakes. We're very careful. There was a mistake last year, but it was very unusual to have a mistake. Right, yeah, you could. So this is a little bit of a trap, I suppose, for people a little bit of track for people who know about advanced mathematics. That if you know about the product rule or something like that, then you could feasibly go and differentiate this with the product rule, which is exciting higher level mathematics. That would be a lot of work, and I don't really want to. Remember that MAT questions are written for people who MAT questions are written for people who don't necessarily know the product rule. There's no product rule on the MAT syllabus. If you know lots of extra mathematics, then sometimes it's helpful to remember that we wrote these questions so that people could do them even if they didn't know as much maths as you. And now somebody would like me to take their exams for them, which would be, I guess, effective, but not very fun for me. Okay. Good. People discussing the merits of having hints or not. Let's have a quick look at the results on this poll. Oh, it's interesting. It's very interesting. Here's the vote. Here's the voting at the moment. Voting at the moment is currently on. 61% of people have voted 7 for the degree of this polynomial. 28%, next most popular, have voted for less than 7. And then some people have voted for 8 or 9 after that. So, everything to play for. Let's go back over here. I see, people in chat now offering to check the map for me, I see. Fixing both, right, okay, good. Oh, have I not turned replies on? Somebody's pointed out I never turned replies on. Let's fix that. Sometimes I turn replies off if I'm worried that chat's got too rowdy. Right, okay, let's get rid of that. And have chat on instead. There we go. Good. Right, okay, let's talk about the question. I can see why people have selected the answers that they've selected. Because, as Flora was just saying, when you look at a polynomial like this thing is a bit like, so this term here in round brackets to the power of 4, this is a bit like something times x to the power of 4. And this term over here, 1 minus x to the power of 5, that's like something else times x to the power of 5. So this is a polynomial inside the square brackets of degree 9. X to the 4 times x to the 5 is x to the 9. So when I differentiate it twice, I'll end up with something like something times x to the 7. Okay, that's looking pretty good. Similarly, over here, when I look at this term, this thing looks like something times x to the 4. This term looks like something times x to the 4. So when I multiply them together, I'll get something that's like x to the power of 8, plus a whole bunch of other terms. Loads of stuff going on in here. And when I differentiate it, I'll get something times x to the 7. And it's going pretty. It looks like a polynomial of degree 7. So I can see why lots of people chose 7. But as chat is trying to explain underneath right now, this is one where we need to worry about the coefficients. In the warm-up, everything was fine. The coefficient of x to the highest power was just 1. It was just one source of that highest coefficient term, one source of that highest power term. That was where it came from, and we could see that its coefficient is 1. Importantly, coefficient of 1 means it's definitely there. This one, it turns out that the terms cancel out. And someone says in chat, will the terms cancel each other out accidentally? That's exactly what happens here. I'm going to go through and fill in the question marks to check that coefficient. Because remember, the polynomial x squared plus 1 is degree 2. It's not degree 10, even though you could write it as 0 times x to the 10 plus x squared plus 1. There's a power of 10 here, but the coefficient is 0. So this is not really a polynomial of degree 10. This is a polynomial of degree 2. Okay, so we need to be careful with these coefficients. Let's go and put some of them in. This one here is 8 times x to the 4. No, 16 times x to the 4. 2, 4, 8, 6, 16 times x to the 4. And this here is minus x to the 5, so this would be minus 1. So inside the brackets, I've got, I think, minus 16x to the 9 plus loads more stuff. Okay, I'm going to do 2 derivatives of that. I'll do those in a moment. Over here, I've got, what is this? This is 2 to the 4 again, isn't it? So this is 16 times x to the 4. And this thing over here, the coefficient of x squared is 9 because it's 3 squared. So inside the square brackets, I've got 16 times 9 times x to the 8. Oh no, because when I differentiate this one twice, I'll end up with minus 16 times 9 x to the 8, differentiate it again, times 8 x to the 7. Got to be careful with my x's here, haven't I? Times and x's. Over here, when I differentiate this one, I'll get 16 times 9 times 8 x to the 7. Oh no, these things cancel out. This one's got a minus sign on, and they're both 16 times 9 times 8. I don't need to work out what number that is, I can see that they're both going to cancel out. So actually, oh no, the x to the 7 terms cancel. So this is actually a polynomial of degree less than 7. Oh no. Okay. Right. There's a terrifying question, wasn't it? Someone in chat just says despicable, and they're anonymous. So there you go. There's some feedback. Okay. Good. Somebody's asked, what does it mean to be a polynomial of degree x? And that's the highest degree. So this is a polynomial of degree 3 because the highest power is 3. Actually, if I can put a 4 in here as well, it's still a polynomial of degree 3. And this is a polynomial of degree 10. The terms don't have to be written in order. It's the highest power of x that appears in that polynomial. Okay. Quick note on what degree is, which is also somewhere in the revision page a couple of pages ago. Okay, I thought I'd start with this one because it's the scariest and hardest out of the ones I put on. It sounds a bit horrible. Right, cool. Okay. Somebody's called me cheeky for that. I didn't write this. Okay. Right, good. We're going to do a friendly one and look at a long question and then call it a day. Let's do a more friendly one. Yeah, let's do a kind of warm down as we get up to 6 o'clock.
Someone's linked it with the warm-up question, how polynomials link with its derivative, which is good.
Ah, yes. There you go. You can think about integrating instead of differentiating as well. Okay, right. Okay, we're going to do 2013 question 1a next, I think. This is a bit like the question that we started with, thinking about whether this quadratic has distinct roots, two different roots, or not. This question says distinct. Distinct means not the same as each other, and it's got the word real in. So all you people who love complex numbers, looking for real roots here. And we would like this quadratic in here to have distinct real roots. Okay, somebody's pointed out that I'm a little bit behind, which is true. But somebody asked at the start for more warm-up questions, so we got more warm-up questions. Okay, I'm going to do a poll again, because I like knowing how you found these questions, and I'm going to start talking about it. I think I'm going to start talking about it straight away. Okay, so this is a classic discriminant of the quadratic question. You've got to be careful, partly because there's a 1 on the right. I need to remember that when I'm talking about roots of equation, I'm talking about thing equals 0, so I've got to remember not to get confused by that. This is a minus 1 equals 0. Bring the 1 onto the left-hand side. Okay, first thing I might get wrong, I suppose. Second thing I might get wrong is that my discriminant is about b squared minus 4ac, where in this question a is not b and it's not c, it's, oh my word, the letter a is just in a strange place in this quadratic. That's what I'm trying to say. Okay, but my discriminant is b squared, which the second coefficient squared, minus 4, first coefficient, last coefficient, and I want that to be strictly positive for two real solutions. For two distinct real solutions. Okay, I know this quadratic. This is a squared minus 4a plus 4, which actually factorizes, doesn't it? I want a minus 2 squared to be strictly positive. Okay. Yeah. People in chat reminding me to subtract 1. 4 people have told me to remember to subtract 1 from the other side. Let's just quickly for posterity. There you go. This chat recently, just remember to subtract the 1, James. They know what I find difficult.
Exactly.
Happy to help out. Good stuff. This is a bit of a strange equation because this square on the left, squares are positive, right? Squares are positive. The only way this could go wrong is if this square is equal to 0. So what I want is a to be not 2. If a is 2, then this thing on the left is 0. Oh dear, it's not what we want. Otherwise, squares are positive, so we're fine. So we must have a not equal to 2, which, oh yeah, it's also won the vote. Brilliant stuff. Oh, and I can see why people have picked B. So if you're rushing a little bit, then you might square root both sides over here. You might say, I want a minus 2 to be positive. But that's not quite correct. That we don't want a minus 2 to be positive. A minus 2 could be a negative number. Negative numbers also square to positive things. This is like, last week we had something like this as well. It's like thinking about when is this quadratic in A? When is this quadratic positive? And the answer is almost always, except not here. Okay, good. I can see why people picked B for that one, but yeah, good to see A winning. Ah, good. Okay. And people in chat, not too bad. Yeah, cool. Do I help with STEP exams? Practicing for the MAT at this point might be helpful for STEP because we're revising the kind of core content that you do need to be able to do for STEP questions. Okay. STEP involves lots of other maths as well. STEP is a different maths exam if you haven't heard of it. It's a maths exam used by other universities.
Which will not be named.
I don't know why we're not naming Cambridge. Okay, right, good. Only a bit easy. People want to do 2016. Can see one person who wants to do 16. Yeah, okay. So it's talking about when x squared plus 1 is a factor of this mess. Is it for all values of n? Just the even ones, just the odd ones? When n is sufficiently big? Or never? X squared plus 1 might never be a factor of this expression. We are accelerating. Cool. Okay. This looks really unfamiliar and weird, which is something that math questions do quite a lot, to take factors of polynomials, which is something we know about and like, but do it in an unfamiliar way to talk about this. I've got a way into this question though. You see, I know two ways into this question. One of them's just been suggested in chat, which is to try substituting in some complex numbers. Chat, I think your moment's come. In the 8th episode of the Oxford MAT Livestream, I think this is your moment if you want to use complex numbers for a thing. If you've been waiting for complex numbers to turn up, then I think this is genuinely your first opportunity on this show. Because the factor theorem is actually true for complex numbers as well. So for x squared plus 1 to be a factor, x plus or minus I, those would both need to be factors of this expression, which is equivalent to plus or minus I being roots of that equation. So if you know complex numbers and you know the factor theorem is actually true for complex numbers. So off you go, plug in plus or minus I and see what happens. People are going for it, looking at whether they can do things. We think zero is neither positive nor negative.
I was going to say, I replied with my stance. It's neither.
Yeah.
No.
Last week, I think last week I suggested that somebody maybe believed a positive number to include 0 or the other way around or something. I'll maybe retract that opinion from last week. It wasn't my opinion. Anyway.
Yeah, but I think in my opinion the phrase non-negative implies that that's when you want to include 0. So. Oh
wow. Okay. Concept of positive versus non-negative. Good stuff.
Exactly.
Right. Okay. So people might be plugging in I and minus I. That was one method that I saw in chat. People in chat obviously love that method because complex numbers. If you don't know about complex numbers, then I want to show you a completely different way of approaching this question, which is that the objects in here look unfamiliar because we're not talking about x plus 1 being a factor. We're talking about x squared plus 1 being a factor. We can do a sort of change of variables to something like u equals x squared. If we do that, then we're talking about whether u plus 1 is a factor, which is something much more familiar. I mean, okay, it uses the letter u, but bear with me. That's something much more familiar because the factor theorem relates together, saying whether that's a factor and whether minus 1 is a root of the equation. Okay. So if we do that change of variables, then we're looking at 3 plus u squared to the power of n minus u plus 3 to the n, u minus 1 to the n. And running through there, we now want to think about u equals minus 1, because u plus 1 is a factor if u equals minus 1 is a root. if u equals minus 1 is a root, then we'd be looking at 4. So this would be minus 1 squared is 1, 4 to the n, minus, and then this thing over here would be 2 to the n, and this would be minus 2 to the n. That's not always true, because this second term has got rather a lot of minus signs on. I think I want n to be even. So a quick cheeky look at chat. Oh yeah, chat's with me as well. I think I want n to be even so that all of these minus signs over here in zoom, let's go mega zoom. I think I want n to be even so that all of these minus signs multiply out to 1, so that this minus sign cancels the two terms and I get 0. So this is my question. Is this thing equal to 0? If this thing is equal to 0, then minus 1 is a root for u. If minus 1 is a root for u, then u plus 1 is a factor of the original polynomial. That happens if n is even. Okay, undo the crazy zoom. Okay. So I think I want n to be even, which is, I think, also the solution that you get out of thinking about complex numbers or some other method of doing the question. Oh, chat's with me at about 80%, which is nice. I saw quite a few people voting for no values of n, which I get, I suppose. You might get through to here and think that u can never be minus 1 because u is a square, which sort of does make sense, I suppose. I'm sort of slightly uneasy about the way this question's very close to playing with complex numbers.
Yeah.
What is it? The fundamental theorem of algebra.
Algebra.
Something involving complex numbers that's not on the syllabus, because we don't have complex numbers on the syllabus. I think this question is a little bit too close, perhaps, to use of complex numbers. Really like to see if people in chat are hanging around and can tell me why they've picked that one. Picks no values of n. If someone's got like a good justification for that, be really interesting.
I don't know if you saw this in chat. Someone said they just tried values of n is 1, 2, and 3.
Oh, 2 should have worked. Let's check.
Yeah, I'm thinking that, and then they said that gave them their answer.
Chat loves checking small values of n. Checking small values of n.
I suppose that might give you the answer.
Might. Well, I suppose. Oh, I suppose. Yeah, right. Because we're going to discover that this. We're going to discover that this works. If we check 1 and 3, then they won't work. So it's a little bit cheeky.
Yeah, and so then you know that it's not all n, it's not odd n, it's not even n,
yeah.
And it's not n greater than or equal to 3.
It's not just n greater than or equal to 3. It's because it's also going to work for 2, isn't it? If I can multiply this out. My word, I've really committed to doing this multiplication out now, haven't I? It's too late to back out now. Oh no, it's going really badly. Minus 2x squared. There's a 2 in here. Ooh, it's gone really badly. Oh, I don't like this method at all. I've got to multiply out all these polynomials. Oh my
yeah,
God,
this is the thing. It's a bit of a brute force method, isn't it?
So I get some x to the 6's. Who suggested this? Oh, this is so much work. 6x to the 4, and I get minus 2. I've done something wrong, I think, because this is not quite balanced. I don't know what I've done wrong. 6x squared and 9, and I've got, keep going. And then it cancels, and it's amazing.
Yeah,
it works.
and then it all works.
Yep. Somebody wants to do the n even step here is just think carefully about all the minus signs to realise why that implies that. Think carefully about these minus signs and what happens to minus 1 to the power of n. Okay, people want a bit of 2 even though we're running over time, so we're going to speed run question 2, if that's all right. Flora, I know you've got to dash in a mo, but we're going to do question 2. Let's just see what happens. It is 6:05. There's about 100 people watching. I haven't done this question for months. Let's have a go. It's one of my favourite styles of question where we've got an expression like this and it's got some parameters in here, a and b. They appear in the equation, and we're asked for properties of this. We're asked to show that if x equals 1 of us is a solution, well, so when I plug in x equals 1, right? That's a good start. I want this to be true. That tells me something about b. But hang on a minute. I know that a squared is is positive, right? Is that good enough? Feels kind of just about good enough, doesn't it? Have I got all those ones correct? Oh, maybe I should not be speedrunning this question. No, I obviously should. Ali's done this question. Okay, so I think that means that 1 plus 2b minus b squared is equal to a squared, which is definitely bigger than or equal to 0. I'm trying to force an inequality to appear in this question, and I don't want any a's in the thing that I'm doing, so I need to replace a with some fact about a that's an inequality. The only thing I can think of is that a squared is definitely positive. Okay, so that gives me that b squared, I'm going to flip the signs around as well. It's definitely negative like that. Now, what am I going to do here? I suppose I could try completing the square. I'm thinking about completing the square because I want this kind of b, I want some kind of limits on where this is true. I'm thinking about this quadratic for b. I'm thinking about, you know, where is this thing negative? If I complete the square, that'll help me write that, I think. I can complete the square like that, and then I find that, aha, now I'm really doing well. This b minus 1 squared is smaller than or equal to 2, which rearranges to this thing here, doesn't it? There's a plus or minus root 2, and there's an add 1 to both sides. Okay. Part 2. Show that there's no value of b, so it's impossible, there's no value of b for which x equals 1 is a repeated root of star. Okay, so for me, x minus 1 being a repeated root would mean that this term is sort of like that. That the left-hand side here, this cubic would have to be equal to x minus 1 squared times x minus, I don't know, some number a, for some value of a. If 1 is a repeated root, then there's going to be some linear term in here factorising the cubic. Okay. Oh, is YouTube down? Cool. Okay. Then I can multiply out. I could multiply that out, and I'll get some equations. In particular, I'll get an equation for this coefficient in here, the coefficient of x squared, and I'll get an equation for the constant term. And I think those are going to be inconsistent. How am I doing?
You're doing good.
Okay. So the constant term is going to be 1 times minus a, which would have to be equal to minus b squared. That looks suspiciously negative. Is this good? And the coefficient of x squared would have to be, I get minus a times x squared from multiplying out the x squared in here with the a over here. And I also get minus 2 from having the minus 2x squared from this bit and the x over here. So this is the coefficient of x squared, be 2b. Okay, what am I doing? So then I could try and rearrange this. Minus a would be 2 plus 2b. I can solve these a little bit, can't I? I can write 2 plus 2b would have to be equal to minus b squared. This polynomial has no solutions. This has no solutions. I can see that it has no solutions. Maybe by using the discriminant, or maybe by completing the square again. But this thing is definitely positive. So no solutions. Okay, so no values for b. Good, okay. Looking for turning points. If I know there's a turning point at x equals 1, then I can think about the turning points. Yes, okay, quickly, turning points. If there's a repeated root, then x equals 1 would have to be a solution of the equation for where the turning points are, which is this equation, 3x squared plus 4bx minus a squared. X equals 1 would have to be a solution of that. But that's impossible? Doesn't look impossible. Is that impossible? That doesn't look very impossible. I think this b squared matters. Okay, I don't understand how the turning point argument works. Somebody wanted to do that in chat. Sorry, I don't get it. And I'm speedrunning the question because we're past 6. Okay, cool. It was a nice idea. I'm sure it can be made to work. Cool.
Some people were asking about whether you're going to speedrun a math paper.
Yeah, we do. Well, there's an edited 10-minute video that goes up each year. I've nearly done 10 minutes on this question though, so you know.
Yeah, that does sound difficult.
it is edited for the 10-minute Matt in 10 minutes or less is highly edited. But you know, we could do. I kind of want to do like the speedrunner, have the timer on the screen, and just
Yeah, that would be quite
through,
impressive.
You know, do the
But
proper speedrun.
quite high pressure as well.
Problem is, I've already seen them pass papers, and also, I guess the proper way to speedrun it would be to try and do it explaining it properly as you go, but at speed.
Yeah,
Yeah,
because you have to.
My job is. Okay.
Someone's saying good things about Cambridge. I almost didn't want to approve that, but
Oh, we like Cambridge. I think Cambridge is.
it's the other place.
Yeah, nothing wrong with Cambridge. Okay.
Nothing wrong with it.
Oh, right. Okay. This is quite exciting. This third part. If x equals 1 is a solution, and we want this to have a repeated root, then 1 can't be the repeated root. This is not repeated because we showed in part 2 that x equals 1 is not a repeated root of equation style. There's no value of b that works for that. So it would have to be something like this, where 1 is a solution and there's something else which is the repeated root. That's equal to the cubic at the top, and then we can solve. And solve for what that equation b is. I think it turns out that minus big B squared is equal to minus small b squared, which is good. And then also something else, something to do with a? No, also the x squared coefficient is going to be something like minus 1. Why am I speed running a math question? This is just such a terrible idea. Minus 2bx. Minus 2bx inside here, so minus 2b. That would have to be equal to 2b, so then this is equal to big B could be plus or minus b. Solve. I'm sort of writing solve to go and plug that in and solve the quadratic. It looks like plus or minus 1 to me. It's not 1, so it's probably minus 1. Something like that. Okay, good stuff. Right, for that value of b, I think, by the way, I think this might be part 4 of the question. For this value of b, does that cubic have a maximum or a minimum and its repeated root? And I think this is talking about whether this cubic looks like this, or does it look... the cubic looks like this, and we want to know, is the repeated root a point where you're like this, or do you have a minimum at your repeated root, which would be like this? And a good way to tell is to think about the other root. By this point in the question, we've solved this algebra that I got bored of solving, and we've worked out that we know the other root might be bigger or it might be smaller. That's the difference between these two cases. That helps you identify whether this thing has a maximum or a minimum at the repeated root. Okay, cool. I can't remember what the answer turns out to be. Someone in chat will have done this question. Yeah, cool, good. Okay, putting it together, I think we've got different values of b. We're going to solve this. Good, okay. I sort of feel like I should have solved this algebra. I'm running out of steam.
It's okay. Some people are coming up with funny ideas for Matt, but every minute everything is integrated.
Oh.
Matt, but all the numbers are complex. A kind of like variations on the Matt series.
Matt speedrun, but every time James makes a plus or minus sign error, it gets faster. Oh, that
exactly.
Right, cool. Okay, good times. Right, I think I'm gonna stop doing the math. I'm gonna try and take some questions because I missed some admissions question stuff in between. Yes. I think Flora's got to run off. Thank you, Flora.
Yes, I have got to head off today, but I will see you all soon, and hopefully I can get the internet working better next week.
Okay. Thank you for coming along. Thanks to people who have hung out for that kind of a mess of a long question. Don't forget, on the actual mat, you get some blank paper to try it on next to the question. You don't have to answer in between the parts of the question like me so that everything fits on screen, because you won't be live streaming your mat solutions. Right, okay. Thank you, Flora, says Lily in chat. Good. Okay.
Thanks, everyone. Bye.
Bye. Okay. And then it's just me and just chatting. And I'm going to try and work out that value of b. Okay, let's close that. Hopefully that doesn't break anything. Cool. Okay. Will wants to know if Oxford Online Maths Club is starting again next week. Will, we're starting the Maths Club again at next term in January. We're going to keep running this for a bit. This is going to be the 5 p.m. slot, and then in January we're going to switch back to the Oxford Online Maths Club, which is a bit like the style of this, but more relaxed and maths that's not just maths admissions test maths. Okay. We'll get the further maths question in chat. So are you at a major disadvantage if you're applying for maths or computer science courses without further maths? And I suppose if you're doing A-levels and you're missing out on further maths, that might be because your school's not teaching further maths, which is one thing. It might be because you chose not to do further maths. So there's kind of different reasons why you're not doing further maths. I think you've missed out on some maths. You miss out on complex numbers if you're not doing A-level further maths, which is a shame, but you can learn that stuff at university. So I wouldn't say major disadvantage. In terms of the maths admissions test, there's no further maths on here. So you're not at a disadvantage there. If you're good at solving maths problems, then you should be able to have a fair attempt at the things like the maths admissions test for Oxford. We do usually like it when people decide to take further maths if it's offered to them. We know it's not offered to everyone, so it's not quite required. But in practice, lots of people who are applying for maths are doing further maths because they had the option to do it and they wanted to. People in other school systems and other education systems around the world, I know that further maths A-level is not a thing around the world, and that you might be doing other sort of qualifications where you might be doing different sorts of maths, you might be doing as much maths as is available to you. So my advice about further maths just applies to A-level further maths. A-levels in 2020, applying for 2022, would it count to a third? Probably didn't see it. So policy for this, I suppose, for the maths department, if you're doing maths then further maths, that's fine with us. If you did an A-level in 2020, that's like 2 years ago. If it's not maths, then it probably doesn't count towards our standard conditional offer. We make this special exception for people doing maths in year 12, further maths in year 13, because we think that's quite normal and fine. But in terms of workload, we're looking at, in other cases, we're looking at workload, we're looking at how much work people are doing over those last 2 years. It makes no difference to us for workload reasons whether you're doing maths and further maths in 1 year and 1 year, or if you're doing maths and further maths in parallel. But yeah, okay. Someone says they go to Cambridge. Can you watch this stream? Yeah, sure, fine. Hi. Stream's just on YouTube. I love it when people ask if they can watch the stream. Like, if you have access to YouTube, then it's there. I really can't stop you, and also don't want to stop you. Right, cool. This is the maths and stats question. I get quite worried sometimes. So maths and stats is not harder to get into. Maths and stats has fewer places than the maths course, but we're looking for the same standard of mathematician. We're able to take either a maths candidate or a maths and stats candidate in some cases. So sometimes we're looking at similar candidates, and it's turned out in recent years that the maths candidates, when it comes to it, have been slightly stronger, especially at the borderline, which is why we've ended up taking maths candidates more as a proportion of the number of applicants. But I don't think you should let the number of applicants is kind of not important information to you, I think, or it's not as important as some people think. The number of applicants tells you about sort of how popular a course is. It's not necessarily the same thing as the strength of applications. Okay, right, cool. Is it a quarter and minus a quarter? Thank you. People's usernames, come on. Something about a quarter and a minus a quarter out of this equation. It's a bit suspicious. I might have made some mistakes somewhere else then. I recognise the number quarter and minus quarter, possibly. Maybe, and then there's a 2. And that's also a b. Oh yeah, that's not a b squared. That's a normal b. Okay, yeah, cool. Capital B could be equal to plus or minus small b. There's 2 cases. If b equals minus b, then this is minus 1 equals 0, which is wrong. But if b is equal to big B, which is probably what you would write down when you saw that equation, then you can rearrange this to be 4b is minus 1, I think. Yeah, so then b is minus a quarter. Thank you. Cool. Would I recommend doing all the Math House papers? How many should I do? At this point, I'd say do a few of them. You don't need to do all of them. We've put them back to 2007 because that's when the test changed quite significantly, but that's loads of questions. Do a few, do something else, do other questions. Anything else you find difficult should be good preparation. Somebody's tried to rickroll me. They've labelled it rickroll though. Thanks, Emily. Is there a formula to decide? Yeah, okay, here are two questions at the same time. Is it true that you need 80% for interviews? And is there a formula to decide who gets an interview based on maths score and GCSEs? The answer to both of those is no. We look at the rest of your application. So we do look at your previous grades, we look at your predicted grades, we look at your maths score, we look at your personal statement, we look at everything together, and we don't have a formula, we don't have an algorithm. We get humans to look at it and decide who they want to interview based on all that information. Maths the most important thing because it's a maths test that you do relatively near to the time that you would start the course. Maths the most important thing, but we also look at the rest of your application. We look at you overall. Cool. You asked, how am I doing today? I'm doing well today, thank you. Good. Yes, and the admissions rate, let's talk about that, come on. I'm going to say nice things about maths and stats today, I think. The admissions rate is the number of offers made divided, which is relevant, right? It's the number of places on the course. Number of offers made, relevant to you, divided by number of applicants, which I think is basically irrelevant to you. Number of applicants is a sort of weird nebulous concept about how many people are turning up to do the maths and then not get shortlisted for interview. It doesn't affect you as much as you think it might. If you're good, then the number of applicants, completely meaningless. In a sentence, and this is maybe too extreme, if you're the best, doesn't matter how many people there are who are not the best. You don't have to be the best, so that's not a great sentence, is it? Because people are going to take the wrong way. But if you're good, then it doesn't matter how many people are worse than you. Like there could be twice as many people who are worse than you, and it doesn't matter, right? Changes the rates and the numbers. Doesn't affect your life. Right, cool. Most effective, most important aspects of getting shortlisted for interview. For maths admissions test, and then other stuff. Abigail says, what order do I do the questions in? Or past papers in? I would start with 2016. I would go 2016, 17, 18, 19. That's too many. I would maybe start 2017 and go 17, 18, 19, 20. I would do those four. Starting 2017. In fact, that's pretty much what we're doing. In a couple of weeks' time, we'll start looking at some past papers, and we'll go 18, 19, 20. The more recent ones, 2018, 19, 20, are with the new syllabus. The syllabus changed very slightly, so those ones work really well as past papers. The older ones have got some weirder questions that use maths that we don't ask questions about anymore. Let's have this. Is there a live stream on recursive stuff and other things related to questions 5? Which, hey, yes, in 2 weeks' time we've got a live stream on recursion. Good. Does Oxford prefer? Hang on, is Matt a teacher? Matt is the name of the maths test, maths submissions test. It's the one where the questions come from. Ranking things. People want me to rank things. Oxford prefers the maths. Oxford writes the maths. Oxford uses the maths to for all the maths submissions. Oxford does not use STEP. Cool. Did I miss an F1 driver question? What did I miss? I completely missed something about F1. Goodness knows. Okay, good. Right. There's other questions from before. During the mat creation question, when a colleague runs a potential long answer question by you, do you try and do it as if it were an exam? Yes, I try and do the questions when people write them for me. Do you speed run it? I guess so. I try and do it carefully and get it right. How long would that take me? Some of them take me a lot longer. I do lots of terribly bad or terribly difficult math questions so that you don't have to. And I do some math questions that are a bit too easy, but some of them take me absolutely ages. But yeah, there's a good impression of how question setting works. People write questions, we try and do them. Not just me, a team of people try and do the questions, then we try and make them better. Somebody wants to know if they should do maths or maths and computer science, which is a good question. It depends if you want to study computer science at university, I guess. Right, cool. Good. Losing track a bit. Let's approve some more questions and see what's going on. Stephen wants to know about open applications. Stephen, hi. If you make an open application, if you don't choose a college, then the very first thing that happens to your application is that we assign you to a college. We use a random algorithm to do that. We assign you to a college, and then you're treated exactly as if you applied to that college. So it's not an advantage, not a disadvantage. You don't get special consideration with the other open application people, none of that. You just get given to a college and then treated exactly as if you put that college down on the form. It's an option if you don't care at all, and that's it. If you care at all, then pick a college and apply to that one. But it's not easier, it's not harder, it's not even different. You get treated exactly as if you apply to that college. The people assessing your application don't even know. Okay, good, right. Is this going to be an A-level maths for someone? Which is a good question. I suppose this is A-level maths, isn't it? This sort of thing involves, this sort of thing is on A-level maths. If you're not doing A-level maths and you're about to do A-level maths, and hey, you're going to learn this sort of stuff. Are there any books I recommend? There's a really good book called Advanced Problem Solving by Stephen Siklos, which is free and online. Don't pay for it, it's free. It's got lots of step questions and methods to try doing them. It's a bit of an inspiration for the layout on these questions, where there's a bit of question, a bit of hint, and the solution is somewhere else. Okay. Any place to revise core topics besides regular school? Besides regular school, and this is not supposed to be a replacement for regular school, but every worksheet that we're doing for this MAT livestream, there are 10 of them, and this is the 8th one on the MAT Live website down there somewhere. Has a revision section where we just run through what does the material mean, what are we expecting people to know in detail. How much mathematical physics should I include in my personal statement? I'm interested in it, so fine, go for it. But do Oxford prefer pure maths applicants? No, you can talk about mathematical physics if you want to. We don't have a bias like that between what sorts of maths are you interested in. And somebody wants to know about four A-levels, more likely to be considered with good predicted grades. Not really. The 4th subject is probably completely irrelevant, to be honest. Probably your 3rd subject is a bit irrelevant to maths at Oxford, so no advantage to doing 4 A-levels, sorry. I mean, obviously, you're learning more stuff, which is a reason to do 4 A-levels if you've got that option, but not really an admissions advantage. If we make you an offer, it's probably going to be based on 3 of your A-levels. Okay. Am I watching Bake Off next week? Yes. That's a weird question, because Bart has asked me, am I watching Bake Off next week? As if you know that I missed it this week. It's weird, isn't it? Okay. I might be overthinking things, or getting paranoid. Cool, yeah, no, I missed it, but I promise I'm going to catch up with Bake Off. Okay, recent math papers seem to have more explain questions than previous papers. Is this conscious? No. Is this a good idea? Yes. Explain questions are really good, because they give you a chance to actually explain what you're thinking, rather than doing boring calculations. Is this one a bit older? I can't remember. This one's got some... So explain that questions are like the way this question has, show that in it, and show that, and then just a question for the other parts. But I quite like show that. Okay. Easy question is coming in. Here it comes. I'm doing AS exams in October, finished my A-levels. Am I at a disadvantage for not having AS grades? No. Lots of people don't have AS grades anymore. In the UK, lots of people don't have any AS grades. Not a disadvantage, we just know that's a fact about this. Algebra says, I've already asked this, but I think it got buried. What's your opinion on paid MAT courses? Boot camps, tutors, worth it or not? So I'm going to a lot of effort to organise a free MAT course. If I put any paid MAT tutors out of business, then there we go. That's the thing, and I'm not sorry. I don't recommend or endorse any of the paid MAT courses out there. I know that there are people charging ludicrous amounts of money to practice MAT questions. Cool, right, good. Question about gap years. Does it influence your chances to get to Oxford? It can have... There's one thing that could really influence your chances to get into Oxford from a gap year, and that's if you spend a year not doing any mathematics, then probably you're going to get quite rusty at the kind of boring technical stuff. You get rustier at that, and maybe you forget some of the concepts, or you forget some of the ideas. You have fewer things in your toolkit unless you keep your skills sharp, unless you keep practicing doing maths over the gap year and practice doing challenging, tricky mathematics things as well. It is the only way to make sure that you're still prepared to then do a really challenging maths course like Oxford Maths. So the reason I normally talk about gap years in those kind of tones is that I'm worried about people trying to start the Oxford course after a gap year if you haven't done enough maths over that gap year. Okay. Is the solution on the MAT website an outline or the bare minimum? It's often the bare minimum. I'm trying to go into more detail on the MAT livestream. Not on this one. This one is bare minimum, right? Not even quite the bare minimum. But I'm trying to do more explanation of where I got to the solutions on the live stream. On the MAT website, the official solutions document is a bit more minimal in places. Conversion between AP and IB. Oh my word. What is like a conversion between AP, and that's advanced placement tests, and IB, that's the International Baccalaureate score? Like what is 3A star? We've got an official interpretation of what 3A stars. Hang on. We've got an official interpretation of what A star A means in terms of those other qualifications. If you're doing APs, we're looking for 4 grade 5s, and if you're doing the International Baccalaureate, we're looking for a total score of 39, including 776 in 3 higher level courses, including 7 in higher level mathematics. You can find that on the website. Cool. Somewhere on the website, if you search for standard conditional offers, Oxford International Baccalaureate or something like that. Cool. Somebody found the 2020 paper easier than previous years, which is nice. Rilo's here. Says sorry. No need to say sorry. Also, if you're watching the replay afterwards because you can't come live at all, then hi. That's obviously fine with me. Predicted grades are something we look at, but we know that predicted grades are not always perfect. We're much more interested in you actually doing maths questions versus predictions about what you might do in future maths questions, which is a little bit what predicted grades are. 4A stars, I already said something about 4A levels, so yeah. If you're predicted A star in maths, that's fine. That's like most of our applicants are predicted A star in maths, and the ones who are doing further maths are almost entirely predicted A star in further maths as well. We can't distinguish between people, so it's not a massive advantage because everyone's predicted great grades. We're going to give you some maths questions to do. I hope that's all right. We're going to actually give you an actual test. Someone says bye. Someone says top of the morning lots of times. Good. Yeah, it's Rilo. We remember Rilo. You were interested in somebody else's EPQ project, and we talked about that in chat with people, so I saw that. Cool. It's Rilo. Not real name. Cool. Right, Scottish hires. Here we go. Can I remember how Scottish hires work? I tried to do IB and advanced placements a moment ago. Hi, Scottish people. I think that the number of advanced hires that you do depends a lot on which school you're at. You might be doing 2 or 3 if you're lucky, and some people seem to be doing lots more than 3, which I don't really understand. We are looking for about 2 or 3, if you can. 2 different hires in 1 year with a suitable replacement with 3 advanced hires. Oh gosh, this is such a technical question. I think it depends what the provision is, right? Like, what were the options available to you? I don't want to say no if that's what you can do, and yeah, I sort of think that advanced hires are roughly equivalent to A levels, but I think sometimes they're a little bit harder actually. So maybe 3 advanced hires is not quite the same as 3. We'll work it out. I'd say apply, do some MAT questions, and then, like all the admissions tutors really, we'll work out the kind of A-level advanced higher stuff afterwards if we want to make you an offer. And probably we'll look at what you're doing in school, we'll know that your teachers know what's best, and we'll work it out from there. Don't be rude to the Scottish people. Bam. Cool. Right, okay, be nice in chat please, people. Go through what degree of explanation is needed. Oh, I'm getting a little bit, okay. What degree of explanation is needed to get full marks of the working? is less than people think, but more than people write. Which is somewhere in between, right? Less than people think. You don't need to go through I'm using the quadratic formula now, here it is, here's the quadratic formula, here's me plugging the numbers in with a equals b equals c equals. You can just sort of do the quadratic formula. So it's less than people think, but it's more than people write. If you look back at some maths that you did in a hurry, you probably didn't write enough words. You probably didn't explain what you were doing. Just by adding in a few words, like an if, then, or solving, comma, blah. Yeah, it can really help turn a string of maths that you've done into a kind of little story with a direction and narrative. Like here, I'm starting here, want to show this, do some maths, so, therefore, done, or something. Okay, good. Yeah, it's 3Ds. Okay. Do people care about? Okay, we're doing predicted grades today. Predicted grades is predicted grades is what we're asking questions about. Is predicted grades of 3 A stars favoured in maths submissions over A star, A star, A? Firstly, that's a question about predicted grades because people don't generally have those grades. Secondly, no, because we don't need you to get an A star in the 3rd subject. Somebody asked about physics a while ago. We don't need you to have physics to do maths at Oxford. We don't assume you know any physics when you get here. And you don't need an A star in that 3rd subject. We're really not looking at the minor differences between people's A-level subjects and people's 3rd A-level grade. We don't need to. We've got a whole maths test where we're going to get you to do actual maths questions. And that's way more interesting to us than A star versus A and, this person's doing chemistry and this person's not doing chemistry. None of that matters as much as, here's a maths question. Please could you have a go at it? Okay, good. Do I like origami? Yeah, I like the idea of origami. I'm not very good at it. I'm not very good at folding. Are visual proofs legal for the maths? Yeah, I suppose so. I would always encourage people, normally when you get a good visual proof, there's some explanation that goes with it to say things. If I'm doing a visual proof of Pythagoras' theorem, then I think my visual proof of Pythagoras' theorem works like this. But there's stuff I say out loud as well while I'm going. So let's try and get this square looking good. I might have a square inside, and my visual proof involves moving this triangle over here and this triangle down to build. What am I trying to do? This triangle. Why am I trying to prove this? Using a visual proof of Pythagoras' theorem to make a small point about proving things in general. I don't know, it just seemed like a good idea at the time. Cool, okay. So on the left, I've got a square inside that's got space c squared inside. That's the gap. On the right, the space is a squared plus b squared for the gap left over by moving the triangles around. So a squared plus b squared must be equal to c squared. There's some stuff I say out loud when I do that kind of visual proof. I think if this was a math question, then I'd write stuff down that I would say out loud. Okay, good. Yeah, math and interviews. Math is on plain paper. You answer in the question booklet, and you can use a ruler if you want to. Good. Okay, good. Okay, we're wrapping up a bit. Oh, whatever. We've got more questions in. Yep, cool. Good. Oh, I missed a load of things ages ago. Sorry, I scrolled. Predicted A, not A star in further maths is something that tutors would be concerned about, I think. But we know that predicted grades are not the whole story. That you might have been predicted a grade because your school never predicts anyone A star in further maths. Or it might be because they didn't have very much information to go on. Earlier I saw people talking about if your prediction is A star B. So this is people predicted to not meet the standard conditional offer, which is A star A for maths at Oxford. If you're predicted something lower, then that's a little bit worrying. But I think sometimes people make up for it by showing that they're actually good at maths and doing things like the MAT and actually... Sorry, it feels really mean to say actually good to mean A star in maths rather than A. That's really math-centric, isn't it? But people are showing that they can actually solve math questions really well. That's more interesting to us than predicted grades. We'd have to have a reason to think that you were going to beat that and meet the standard offer, because it's a legal technicality, but if when it comes to results day, if you don't meet the offer, then legally you haven't met the grades, and that means by default you don't get to start the course. So we have to then intervene at that stage if we want to, which we do sometimes intervene. Okay. Oh my word. Look at this for a technical question. I love the technical questions that come in at 20 to 7. Actually, I've been holding this one for a while. I'm doing criminal. There's a final result of 50 with a logarithmic distribution and a letter grade. What results do we want to see? Internal assessments as well. What do you want for the predicted grades? I want the prediction for what the final grade issued by external people will be. So like the qualification at the end, not the internal assessment or any of the working out. For the predicted grades, your referee, which might be your teacher, will be asked for a prediction for what the grade will be in that qualification that's upcoming. So it's not quite the same as being asked for internal assessment grades or something. It's being asked about what's the actual outcome afterwards. So nothing to do with like the distribution of how you get there or what the raw marks are or something. Just what's the qualification going to be? GCSE results. We think GCSE results might have to be treated differently. We're getting a slightly different data set on GCSE results. Also, we know that GCSE results had a lot of variance in, a lot of inflation, and a lot of different worrying patterns in GCSE results. So I think we are going to have to treat GCSE results a little bit differently due to noise around teacher-assessed grades from this cohort that you're about to apply to university. So where we might have used them a little bit before as a measure of academic potential, this year we're aware that they're not going to be as good an indicator of academic potential, and we're working out what data we're going to get and whether it's reliable at all. I personally don't expect it to be very reliable, so I'm going to be advising tutors not to rely on GCSEs as much as we weren't really relying on GCSEs very much before. I think this year we're going to rely on GCSEs even less. Right, cool. Okay. If you get 10 to 15% higher than the average score on MAT, then you've scored better than the average score. Is that favoured? Yes. More marks the better, please. What about getting even higher? Even better. Good. Technicality question. I like these. Oh. No, not that one. That's the Scottish highest question again. University of Bath. How do you let them know that you're doing the MAT? You need to tell them your MAT registration number. So this is an arrangement with the University of Bath. They'll take your MAT result into account if you tell them that you're taking the MAT. You have to let them know that you're taking the MAT and the M number that you've been given when you register or when your school centre registers you. If you don't know that yet, then pay attention. It's the number that you write on the front of the test. So you'll be given a candidate number at some point. Possibly you turn up to the exam and the invigilator says, here's your candidate number. If you take that number and you give it to Bath as well, then that lets them look you up and look up your MAT score. Without the candidate number, they can't tell your MAT score. So it's your choice. If you give them the candidate number, then they can look you up in a database that I share with them. If you don't tell them your candidate number, then they won't know that you took it. Okay, that's the arrangement with Bath. Similarly for Durham as well, for their maths courses. Oops. Okay. Right. Good. If you're applying as an individual, does it matter who your referee is? There's advice from UCAS on this. It doesn't matter who it is, provided that they can comment on your academic potential and that they can predict grades for you, please. So yeah, there you go. They don't have to be your maths teacher. They don't have to be a teacher, but they can't be someone who knows you personally. And they can't be you. Okay, right. Can we use protractors, compasses, and all other stationery? I think so, yes. I checked once. I think you can use all of the kind of geometry equipment. I don't think it helps very much. So, yeah. Okay, good. Right. Oh, somebody wants to talk about Pythagoras. Thank you so much. Right, here we go. Yeah, graphical Pythagoras proof. The total area. Yeah, so I've seen people write this down sometimes. In this Pythagoras thing, down here, sometimes people label all the sides. And then talk about the area being, let's change colour. The area being a plus b squared minus 4ab over 2 for the triangles. And then sort of similarly, and that's also equal to c squared. which rearranges to Pythagoras. I've seen that approach as well. I quite like it. You don't need to do the translations, but then you've got to do some algebra. And this one says the ancient Greeks didn't do algebra like that, which is true. Cool, okay. And let's do this one. Is applying to Oxford a second time disadvantageous? I think I know what the question means. If you reapply, then we won't link your application to any previous applications. We won't look at data from your previous applications. We won't match you up. And we won't be biased by previous decisions that have been made. We'll treat you as a new candidate, as if you're just someone new who, I guess has the same name, but we probably won't even spot that. So you go through the normal process. You apply, you do the MAT, we choose whether to shortlist you for interview, just like normal. Is it disadvantageous? Well, by this point you're a year older, so you might be expected to be a bit better at maths by being a year older. You might be doing a gap year, so we might look to see, have you got a plan for the gap year? You might have got better at doing maths problems, which would be good. I'd like that. I just love it when people get better at solving maths problems, right? Makes them better at solving problems in the real world too, I hope. Okay, so I'm not going to say disadvantageous because, hey, you don't get to go to Oxford unless you apply. And if you weren't successful the first time, then you don't get to go to Oxford, I suppose, unless you apply again. But it's not very common for people to make successful applications the second time around, partly because it's not very common for people to be successful in some sense, and we have a lot of applicants per place, right? And reapplying doesn't increase your chances massively. It doesn't decrease your chances massively. You're kind of just the same person. So you're applying again. I'm talking very vaguely to say you're allowed to reapply, and we will treat it exactly like your first application. Okay. Favourite proofs? Gosh, I definitely do, but I don't have them prepared. I really like this Pythagoras one on the screen. In pink, so quite hard to see. Sorry, people with needs. Sorry, anyone who needs contrast on screens. Really sorry about that. Let me see if I can try and. Can I put a shape behind? Hey, let's try and make this accessible. That's a fun activity. Okay. Can I fill this? Oh, right. We'll learn to use mirror. Hi everyone. How's it going? That? No, that's highlighter. Filled rectangle? No. Sticky note? Sticky note. Ooh. High contrast mode. There we go. Right, okay, I've enabled dark mode on this diagram. I feel much better now. I want it there. There we go. There we go. I feel so much better. Good. I quite like this proof. There are other nice visual proofs that I can't think of right now, and other proofs where you don't have to write very much down. I've definitely seen some cool stuff. It's really bad that I can't think of things off the top of my head. Yeah, cool. Right, good. Okay, I should have had a cool answer to that question, but I didn't. Okay. What do I think about MAT having a sudden rise in average MAT scores for 2020? I think it's not that important. Sorry. I think the MAT 2020 paper, people, for whatever reason, maybe the paper was easier, maybe everyone that year was a bit better at solving problems, well, for whatever reason the average score is a bit higher. When we're comparing people's MAT scores, we're comparing people who did the same MAT paper, so it doesn't really matter. We look at the differences and we standardise it. So that's not as big a deal as people think. No idea whether this year's MAT average is going to be higher or lower, and it doesn't really matter to me for admissions reasons, I think. Somebody angles a triangle. Oh yeah, okay. Some graphical stuff about angles and triangles. Does Oxford give too many offers, expecting not everyone to make them? For mathematics, we make about 10% more offers than we have places. Not because we're expecting people to not make them. We're expecting people to make them. But because about 10% of our applicants who we make offers to decide to go to university somewhere else instead, which is quite low. Almost all of the people we make offers to start the course in Oxford. Very rare for people to miss the grades. Okay. What if two of teachers write the reference letter? I think that's allowed. I think they're allowed to work together. I'm not sure how it works with naming a reference, and I'm not sure how it works with schools, but I think in practice, some people's references have different sections, I think effectively written by different teachers. which I think is fine and normal. Good, right, cool. There's a question about email addresses that I'll answer in a private reply. A question about predicted grades again. In fact, this question about question about Garden High. Garden High, I will type a private reply because there's an email in there. I'm just a bit iffy about putting it in chat. Sorry, that's why I'm not approving your chat message. Sorry. I think it's fine, but I'll type you that in a private reply. Okay. Predicted 3 A stars. Would I be given 3 A stars? Or would I only need A star, A star, A? You would only need A star, A star, A. It seems a bit weird, doesn't it? That if you're predicted to get 3 A stars, then for Oxford Maths we look at that and we decide to make you an offer, and we look it up in our table that says A levels, A star, A star, A, and then we make you that offer, even though you're predicted to make you better grades. So sort of, you can then go on and get 3 A stars, or you can get A star, A. Either way, that's how the standard offer works. So we kind of set the bar and then hope you get over it. We don't move the bar when we see your predicted grades. So if you're doing 4 A levels, or if you're doing some weird combination of A levels and extra stuff, then we don't move the bar up and down depending on what you're doing. Okay, good. I think I'm actually running out of questions, which is good and nice. I'm also running out of viewers, which is good and nice. I'm going to stop there, I think. We're going to finish with a nice zoom in on this incredible proof of Pythagoras' theorem, drawn in a hurry, pink on white and then fixed. Look at that on screen. Every frame a painting, with the rectangle in there as well that didn't work. Come on, let's tidy this up. Okay. We're doing good. Right, cool. We did some maths, did some questions, worked things out. And if you're around next week's slightly different because we've now run out of math syllabus. So next week I'd like to talk about prime numbers and proof. The session's called Primes and Proof, and we're going to talk about some other math questions and do some other warm-up questions, but not based on a particular bit of math syllabus. We're going to talk about some other things that you're expected to know, just sort of generally know for the math, even though they're not on the syllabus. So things about how to prove things, what it means to explain something, and some facts about prime numbers, because if we're going to talk about proof, we've got to talk about something. We haven't talked about prime numbers yet, and hopefully people know about prime numbers, so they're in the next session. We're going to talk about prime numbers and proof. Someone stressed, don't be stressed. Watch MAT Livestream stuff, or do maths problems. Best way to get unstressed is to kill some math problems by solving them, and that generally makes me less stressed. Okay, good. And I think the one afterwards is on recursion, where we look at some more detailed problems like question 5, 6, and 7, looking at some computer science stuff with a guest computer scientist, thinking about that sort of thing. Wait, no, 4th of November is the one after MAT, Lily. That's the one after MAT, where we're doing something completely unrelated to MAT, because the day after MAT, people probably don't want to talk about the MAT. Right, okay, but more plans on what that's going to be coming out, basically when we get there, 4th of November, day after MAT. Cool, okay, brilliant. And if I haven't answered your question, Rilo, sorry, I think I might have missed your question, Rilo. I'm going to scroll through chat and type some answers, which I'm going to do, starting now. Bye, see you next week.